everyone, welcome back. I am Vandana N from Sri Venkateshwara College of Engineering, Department of Electronics and Communication. Today I am going to discuss a subject called as a network analysis on the topic of classification of electrical network. Introduction to electrical networks. Electrical networks are interconnection of electrical components that facilitate the flow of the electric current. They can be classified based on a various criteria, including their configuration, components, and functions. Understanding the classification helps in the analyzing and designing efficient electrical systems. Classification of configurations. Electrical networks can be classified into series and parallel configuration. In series configuration, all components are connected end to end, providing a single path for current flow. In a parallel configuration, components are connected across the same voltage source, allowing a multiple paths for current. Classification by components. Network can be classified based on the uh, types of components used, such as a resistor, capacitor, inductor. Each component type influences the behavior of a network in terms of voltage, current, and impedance. The combination of different components leads to various network configuration and functionalities. Linear versus nonlinear networks. Linear networks are composed of components that obeys Ohm's law, maintaining properties between a voltage and current. Non-linear network consists of components like diodes and transistors, where the relation between the voltage and the current is not proportional. The behavior of a non-linear network can be more complex and requires a specialized analysis techniques. Active versus passive networks. What is active networks? Active networks means contains a energy source such as a batteries or generator that can be supply power to circuit. Passive is nothing but a network is nothing but a only passive components like resistors, capacitors, inductors, which do not generate a power. The distinction affects the network's ability to amplify the signals and its overall energy management. Time inheritance versus time varying networks. Invariant networks have a permanent that do not change over a time, allowing for simplified analysis. Time varying networks have a parameters that changes with respect to time, requiring more complex methods for analyzing. This classification is important for understanding the dynamic behavior of electrical systems. Two-port networks. Two-port networks are the special type of a network characterized by two pairs of terminals. They are used to model and analyze the behavior of a complex systems through parameters like impedance and admittance. Two-port network simplifies the analysis of interconnection networks and facilitates the design of filters and amplifiers. AC versus DC networks. AC means alternating current, DC means direct current. Alternating current network involves a current that periodically reverse direction, commonly found in households power systems. DC networks have a current flowing in a single direction, typically in batteries operated devices. The classification affects the design's consideration, component selection, and application of the network. Practical applications. Understanding a electrical network classification uh, aids in the designs of a circuits for the circuit means various applications such as a telecommunication and power system. Different classification determines the performance, efficiency, and reliability of electrical equipment. Engineers uses this knowledge to develop innovative solutions that meet a specific industry requirements. Conclusion. Thus, classification of electrical networks is essential for systematic analysis and understanding of electrical systems. Different classification offers insight into the design, performance, and application of networks in real world scenario. Continuous advancements in technologies will further involve the classification and analysis of electrical networks. Thank you, everyone.